We are solving a problem basing on the Stefens law of heat radiation. The problem is like this. A cube and a sphere have same material and having same surface area. So let us talk about that part of the problem first. They are made up of same material, that means density of the sphere equal to density of the cube, and the surface areas are equal, that means surface area of sphere equal to surface area of the cube. So you can say surface area of cube is 6 times of a square, where a is the side of a cube. As it has 6 surface areas, each surface area means a square, 6 surface areas for a cube, therefore 6a square. Surface area of the sphere is 4 pi r square. From this you can write a square by r square equal to 6 by 4 pi. A by r equal to 6 by 4 pi whole power of half. We'll be using it in a later part of the problem. Let us keep that value aside. Now, are placed in an evacuated chamber of the same temperature separately. So, the temperature of the surroundings is same. Now, you may get a doubt that why don't we use a Newton law of cooling? Why not Newton law of cooling? Could be one question that you can ask. Anyway, that's not going to make any difference in this case. Anyway, Newton law of cooling is used when temperature difference between the body and surroundings is small. If it is large, then we shall use Stefens law. So here we are assuming, like as it is not given that they are close to each other, we assume the temperature difference between the body is large, so we'll apply Stefens law. So we apply Stefens law here, as temperature of the body is much bigger than the temperature of surroundings. Assume that they are not close to each other. So what we can say according to Stefens law of cooling, the rate of loss of heat is directly proportional to temperature difference between the body and surroundings. Basing on the definition of specific heat, dq can be written like ms into dt by dt equal to some proportionality constant into temperature of the body minus power 4 minus temperature of surroundings power 4. So rate of loss of temperature, rate of loss of cooling, sigma by ms, temperature of the body power 4 minus temperature of the surroundings power 4. Now, the temperatures of the bodies and surroundings are same as it is mentioned in the problem. So this is not a variable. They are made up of, sigma is a constant made up of same material, therefore specific heat is also same. So the only different parameter is rate of loss of cooling is inversely proportional to mass. So the rate of loss of cooling of sphere to that of cube is mass of the cube by mass of the sphere. Mass of the cube is volume of the cube into density of the cube by volume of the sphere, density of the sphere. Densities are equal because they are made up of same material. So your answer is rate of cooling is volume of the cube by volume of the sphere. Volume of the cube is A cube, where A is the side of the cube, R is the radius of sphere. Let us imagine like so. And the volume of the sphere is 4 by 3 pi r cube. So the answer is 3a cube by 4 pi r cube. Now we can further simplify this as rate of change of cooling, that is dt by rate of change of cooling of sphere to that of the cube, 3 by 4 pi remaining a by r whole cube. But we already found what is the a by r value is, so we can substitute that a by r here. Its value will be 3 by 4 pi. In the place of a by r, I can write 6 by 4 pi, whole power of half is there, and cube is there, therefore it becomes 3 by 2. So the value of this answer will become 3 by 4 pi. I can write 6 by 4 pi whole power 3 by 2 as 6 by 4 pi power of 1 and 6 by 4 pi power of 1 by 2. 1 plus 1 by 2 is 3 by 2. So I have just divided that. So the ratio will be, okay, here I have written not correctly. From here you can write a square by r square as 4 pi by 6. So I have written it in reverse. That implies a by r becomes, a by r becomes 4 pi by 6 whole power of half. That is called that as equation number 1. So here in the place of a by r, I can rewrite the data. Yeah. Yes. 3 by 4 pi. In the place of a by r, I have to write 4 pi by 6 whole power of half, and cube is also there. Now you can write that whole power of 3 by 2 as 4 pi by 6 power of 1, 4 pi by 6 whole power of 1 by 2. This 4 pi can be cancelled. 3 and 6 means 1 by 2. So 1 by 2 whole power of 4 pi by 6 whole power of half. We get this 4 out of this square root. It becomes 2. Remaining is pi by 6 power of half. This and this can be cancelled. So the ratio is pi by 6 power of half or square root of pi by 6. This is how we can find the ratio of the rate of emission of the heat. So here the conditions that were given is, what is missed here is same material, same surface, and at same temperature, but they are of same material, but their volumes are different. That's why their masses are different. So you get a different answer. So the important point here is we apply Stefens law, not Newton law of cooling, and we consider the masses of that bodies because their masses were not same. Your answers are different. That's how we get the answer. Thank you.